Welcome to the En route Wake Turbulence Safety Information Bulletin. The recent advancements in navigation precision and the rising air traffic volume have increased the frequency of wake turbulence encounters in the en route environment. This Safety Information Bulletin will discuss en route wake turbulence, how it affects pilots, and the recommendations and advisories to mitigate the associated risks. Wake turbulence is generated any time an aircraft is producing lift and can therefore occur during any phase of flight. In fixed-wing aircraft, the differential pressure that creates lift also produces counter-rotating vortices that flow off the aircraft's wingtips. These dual vortices are what cause wake turbulence. There are several aircraft characteristics that contribute to the intensity of the vortices: weight, speed, and configuration. The intensity created is strongest in a heavy, slow, and clean configuration aircraft. Aircraft vortices decay over time and distance. In the en route environment, the average persistence of a vortex is 2 to 3 minutes, with an average sink rate of 400 feet per minute. The basic effects of wake turbulence on a following aircraft are induced roll, vertical acceleration, which may be negative, and loss or gain of altitude. The greatest threat is induced roll. Induced roll can cause a loss of control and injuries to the cabin crew and passengers. In the en route environment, aircraft operate at high speeds and have a standard 1,000 feet vertical separation in RVSM airspace. Taking these operating parameters into account, wake turbulence can be encountered within a 25 nautical mile range behind the generating aircraft. The most significant encounters are reported within a range of 15 nautical miles. The awareness of surroundings and risk factors are of great importance, as most encounters are reported as sudden and unexpected. There are no en route separation minima pertaining to horizontal wake turbulence in the PANS ATM. In the en route environment, 3 major factors increase the probability of wake turbulence. In the case that crossing traffic is climbing or descending in proximity, the wake generated may cross the follower's trajectory. In the tropopause, wake vortices decay slower, increasing the risk of encountering severe wake turbulence. Heavy aircraft generate stronger wake vortices, inducing more severe wake turbulence encounters, especially for smaller aircraft. This section displays the typical hazardous trajectory crossing configurations. They are displayed in a vertical plane. Note that the respective flight path may also be crossing on the horizontal plane. When crossing horizontally, the lower the crossing angle, the higher the wake turbulence effect. The variability in the generator aircraft's rate of climb or descent makes it difficult to predict where the vortex is located. Consequently, during the en route phase of flight, pilots should expect possible wake turbulence encounters when other traffic in proximity appears to be on similar tracks ahead, crossing above your level, climbing or descending ahead through your flight path, or when wind direction is likely to move the wake towards your trajectory. As precautionary measures, Operators and pilots should be aware of the following. The passenger address should include an invitation to keep seatbelts fastened even when the seatbelt sign is off, unless moving around the cabin. This reduces the risk of passenger injury in a turbulence encounter en route. For aircraft in the heavy wake turbulence category, the word heavy should be included immediately after the aircraft call sign. This should be said during the initial contact between the aircraft and ATS units. When available, condensation trails should be used to identify the position of wakes and estimate if the flight path intersects them. Pay additional attention when flying below the tropopause, as the probability of a wake turbulence encounter increases. The tropopause altitude varies between seasons and latitudes and can be found on meteorological charts. Upwind lateral offset should be used if the risk of a wake turbulence encounter is suspected, when allowed by airspace regulations, and via specific ATC approval. A change of flight level to cross above heavy or super traffic should be considered when feasible and authorized by ATC. In case of a wake turbulence encounter, pilots should be aware of the following. Be aware that if the pilot reacts to the first roll motion when in the core of the vortex, the roll motion could be potentially amplified. Be aware that pilot inputs may exacerbate the unusual attitude condition with rapid roll control reversals carried out in an out-of-phase manner. Be aware, if the autopilot is engaged, that the intentional disconnection can complicate the encounter. The autopilot in most cases will facilitate the recovery. Try to avoid large rudder deflections that may exceed structural limitations. Although modern aircraft are protected by fly-by-wire systems, typically the use of the rudder neither reduces the severity of the encounter nor improves the recovery. Use the specific guidance in the AOM for the specific type or fleet, if available.
That is correct. That is incorrect. That is correct. That is incorrect. That is correct.